All right, let's talk about something that feels like pure magic in the world of programming. We're going to pull back the curtain on one of the most fascinating spells out there, the fork system call. Seriously, it's a single line of code that literally splits a program's reality in two. So let's dive right in.
So let me ask you something. What if a program, right in the middle of doing its thing, could just create a perfect, identical twin of itself? I mean, a twin with the exact same memory, the same open files, at the very same point in the code. It sounds like something out of science fiction, right? But this is exactly what fork does. And you know, it's not just some neat party trick. This is the fundamental way your command line actually launches new programs.
Okay, before we get any further, let's get one key term straight: process. See, when you double-click an app, you're not just running a program, you're creating a process. Think of it as the living, breathing instance of that application. And that's what we're about to clone.
So, where does this magical split actually happen? Well, it all comes down to one single moment. One instruction that basically tells the operating system, hey, make another me, right now.
This is it. This is the line. When a process hits this bit of code, it's like it steps onto a photocopier. One process goes in, and two identical processes come out. From this exact point on, we are no longer dealing with one program, we're dealing with two.
Now, you're probably thinking, if they're completely identical, how on earth do they know who's the original and who's the clone? Well, this is the absolute genius of fork. They are identical in every single way except for one tiny, crucial detail: the value that this fork call gives back to them. That single number is their only clue to their own identity.
And the solution is so simple and elegant. The original process, we call it the parent, it gets back the unique process ID, or PID, of its brand new child. This ID is always a positive number. But the new child process, it gets back a 0. That's it. That's the only difference, and it is everything they need to figure out who they are and follow two completely different paths.
Okay, so let's follow the original path first, the parent process. It just created a child, and it got that child's unique ID number. What does it do with that info?
The parent looks at the value it got back from fork, which it stored in that variable p. Since that value is the child's ID, it's going to be greater than 0. So it'll skip the other conditions and land right here inside this else block where it proudly announces, hey, I'm the parent and I know my child's ID.
So the whole point here is that the return value acts like a signpost. A positive number points the parent process down this specific path. It's like a private road, meant only for the original process.
But wait, what about the clone? The brand new child process. It's at the exact same point in the code, but it got a totally different signpost. Let's trace its journey now.
So the child process looks at its copy of the p variable and sees the value 0. It follows the signpost for p being equal to 0, and it executes this block of code, correctly identifying itself as the child. It's a whole separate thing now with its own unique ID, which it can figure out by calling getPID.
And that's the whole logic for the child. It's really that simple. Getting a 0 back from fork is the universal signal in this world that says you are the new clone. Go do your thing. The parent and child have now gone down their own separate parallel paths.
So they took different turns inside that if-else structure. But their journey isn't over. And there's one more piece to this puzzle, and honestly, it's the part that trips up almost everyone when they first see this.
This is the key question. The parent went its way, the child went its way. Do they just stop? Or do their paths come back together? They keep going. After their separate special blocks of code are finished, their paths merge again. Any code that comes after that whole conditional block gets executed by both of them. Their private journeys have ended, and they're back on the main road together.
And this just illustrates the result perfectly. Look at the final output from both the parent and the child. Notice they both print that final line, but each one prints it with its own unique process ID. So even though they took different detours for a moment inside that if block, they both continued on to execute the rest of the program. And that's the ultimate proof. We started with one process, and now we have two, running the same code, totally independent of each other.
So let's just do a quick recap. First, fork makes a nearly identical copy of a process. The only thing that's different right at the start is the return value it gives them. The parent gets the child's PID, a positive number, while the child gets a 0. They use that return value like a signpost to decide which chunk of code to run. And maybe the most important part to remember, any code that comes after that conditional block is run by both of them.
And that leaves us with one last really interesting thought. Cloning a program is powerful, but it's still the same program. This is just the first step in how your command line works. But how do you get from a simple clone to launching a totally different application, like your web browser? If fork only makes copies, how does a new and different program ever get a chance to run? Well, that's a story for another explainer. Thanks for joining me.